Let me explain why measuring performance is subtle. Let's go back to our classification task. You've got a whole lot of images with labels. You could say, okay, I'm going to run my classifier on those images and see how many I got right. That's my error measure. And then you go out and use your classifier on new images, images that you've never seen in the past. And you measure how many you get right, and your performance gets worse. The classifier doesn't do as well. So what happened? Well, imagine I construct a classifier that simply compares the new image to any of the other images that I've already seen in my training set and just returns the label. By the measure we defined earlier, it's a great classifier. It would get 100% accuracy on the training set. But as soon as it sees a new image, it's lost. It has no idea what to do. It's not a great classifier. The problem is that your classifier has memorized the training set, and it fails to generalize to new examples. It's not just a theoretical problem. Every classifier that you will build will tend to try and memorize the training set, and it will usually do that very, very well. Your job, though, is to help it generalize to new data instead. So, how do we measure the generalization instead of measuring how well the classifier memorized the data? The simplest way is to take a small subset of the training set, not use it in training, and measure the error on that test data. Problem solved. Now your classifier cannot cheat because it never sees the test data, so it can't memorize it. But there is still a problem, because training a classifier is usually a process of trial and error. You try a classifier, you measure its performance, and then you try another one, and you measure again, and another, and another. You tweak the model, you explore the parameters, you measure, and finally, you have what you think is the perfect classifier. And then after all this care you've taken to separate your test data from your training data and only measuring your performance on the test data, now you deploy your system in a real production environment, and you get more data, and you score your performance on that new data, and it doesn't do nearly as well. What can possibly have happened? What happened is that your classifier has seen your test data, indirectly through your own eyes. Every time you made a decision about which classifier to use, which parameter to tune, you actually gave information to your classifier about the test set. Just a tiny bit, but it adds up. So over time, as you run many and many experiments, your test data bleeds into your training data. So what can you do? There are many ways to deal with this. I'll give you the simplest one. Take another chunk of your training set and hide it under a rock. Never look at it until you've made your final decision. You can use your validation set to measure your actual error, and maybe the validation set will bleed into the training set. But that's okay, because you always have this test set that you can rely on to actually measure your real performance.